Welcome to our education channel from class 6th mathematics chapter number 8 HCF and LCM. Okay, these are the topics I'll explain in this chapter one by one. Let us see some introduction, then what is the factor or factors, next prime numbers and prime factors. Important things from topic number 4 to 9, like common factor method finding HCF, again prime factor method finding HCF, and division method of finding HCF. HCF we have the three methods. Same way, common multiple method to find out the LCM, and prime factor method of finding LCM, division method of finding LCM. So you should know the three different methods to find out HCF and LCM. Right? These are the topics we'll see one by one. When you see this HCF, highest common factor, so that means greatest number that divides each given number completely. For example, 8 and 12. So to find out highest common factor. So there are the factors for 8 and 12. Now 8 and 12, the highest common factor is 4 because the number 8 and 12. So this both divides this 4 completely. That means in 4 table, 8 and 12 both are there. So there is a factors for 8 and 12. 4 is the highest common. So when you see the topic wise, you'll see clearly. Next, LCM is the least common multiple or lowest common multiple. So now for 8 and 12, we have the multiples. 8 table, 16, 24, they are the multiples in 12. In that least, in that common. So that is the 24. When you come to this LCM is 24 for 8 and 12. So these are all the things we'll see topic wise clearly one by one. Before starting the methods to find out HCF and LCM, let us see the factors, prime number and prime factors. Factors. So when you see this word, the factors, when two or more natural numbers are multiplied together, let us say 3 is one natural number, 4 is the natural number. When you multiply these 3 and 4, so you got 12, right? That means whenever two or more natural numbers are multiplied together, the result is referred to as their product. Now each number multiplied is called the factor. So 3 is the factor of 12 and 4 is also factor of the 12. Now similarly, so the product of 5 and 7. So 5 into 7, that is 35. Therefore 5 and 7 are the factors of this 35. 5 and 7 are the factors of 35. Not only 2. Take more numbers. The product of 2, 3, 7. That means 2 into 3 into 7. You just multiply this. 2 3 is 6, 6 7 so 42. Therefore, each number 2, 3, 7. So 2 is a factor of 42 and 3 is also factor of 42. 7 is the factor of 42. So these all the numbers are factors of 42. That means when 2 or more, not only 2, more, any number, if you multiply together the result, which are getting some result now, that is referred as their product and each number multiplied is called the factor. Okay. And next one, 5 divides 20 completely. That means 5 is a factor. 5 is a factor of 20 because 20 divided by 5. If you get remainder, should get 0. Take 20 divided with 5. 5 4s are 20, remainder is 0. That is 5 divides 20 completely. So this 5 is a factor of 20. Same way, 6 divides. Based on this also we can make 6 divides say 12. 6 divides 12 completely. That means whenever you divide 12 by 6, you get the remainder 0. That is 6 divides 12 completely. Therefore, this 6 is a factor of 12. So 6 is the factor of 12. Again for this 6, 2 into 3 is 6. That means 2 is also a factor of 12. Even 3 is also a factor of the 12. Right? Any numbers you can make. Now combining. So how to write the statement wise? Like factors of 24. So this you can write F24. Just write like this. F24 is factors of 24. So which numbers divides this 24 completely? So 1, because 124 is a 24. Again 2. 2 table there's 24, because 24 divided by 2 you get remainder 0. So 3 also completes, 3 is also divides 24 completely. Again 4, 6, 8, 12 and 24 also. 24 also itself. That means factors of 24, 1, 2, 3, 4, 6, 8, 12, 24. Only one thing, which number divides completely, that is a factor. So 3 table, 4 table, 6, 8, 12, 24. 10 is not factor, because 10 table, 24 divided by 10, if you do it not divides completely, we get some other remainder, non-zero. So this is not. So we can find out anything like factors of 30, that is F30. Factors of 30 is, so 1, 2, 3, 5, 6, 10, 15 and 30. Okay. So whenever they're asking to find out the factors, this way. And to even instead of forgetting any value, you can do in this type. 30 you check starting with one table. So 1 times 30 is 30. Next check with 2, right? So 2 15s are 30. Next start with the 3. Check 3, yes, 3 tens are. 4 table 30 is not there. Next 5. So 5 times 6, 30, right? Again next 6 table. Already 6 there is a number. So you can stop this. Now we can write this set in order. This full set. That only exactly equal to this. So factors of 30 are 1, 2, 3, 1, 2, 3, 5, 6, 10, 15, 30. Okay, again if you're getting 6 into 5 you're getting, but already 5 into 6 is there. So no need of writing. You can stop that multiplication product and just write all these numbers together. Okay, in this way we can find out. If you notice, in this set 1 is the common for all. So 1 is the common factor for every number, that means, and itself. So for 20 factors of 24, there's a 1 and 24 is there. That means 1 and itself are the common factors for every number. So 1 is a factor for every number. Every number is a factor of itself. Every number is also a factor of itself. And 0 cannot be factor of any number. So don't take consider 0. 0 into something, you'll never get 30. So 0 cannot be a factor of any number. Right? This is the basic things about the factors. Let's start the prime numbers and prime factors. Prime numbers and prime factors. First let us see the prime number. As we discussed already about the factors, when you come to this prime number, a natural number that is divisible by only 1, and itself is called a prime number. Let us take 2 is the number. Now 2 is divisible by, that means the factors of 2. So when you see this factors for 2 is only 1 and 2. 1 times 2, 2 times 1. So 1 and itself we got. So 2 is a prime number. Now 3. So factors for 3 is only 1 and 3. That means 3 is also prime number. Let's take 4. For 4 factors, 1, 2 and 4 we got. That means this is not a prime number, because we have the factors not only 1 and itself, even 2 is also is there. So a natural number that is divisible only by 1 and itself is called a prime number, right? And let's take the prime numbers we have 5. So only 1 and 5 are the factors for this. 7, 11, 13, 17 and so on. These are all the prime numbers. Every prime number is greater than 1. Every prime number, because natural number. 1 is not a prime number, because if you take number 1, 1 factors are only 1. So 1 and itself is also 1 only. That means it's not a prime number. Remember, 1 is not a prime number. Okay. So the least prime number is 2, and the only even prime number also is only 2. Okay. Every even number greater than 2 is a composite. Prime numbers opposite word is composite numbers. So which are not prime, they are composite. Composite means they are not prime. Which are the prime numbers, which are not prime numbers, they are the composite numbers. So every number greater than 2, every even number greater than 2 is a composite number, and 2 is the only even prime number, right? Because remaining anything, 4 is not, even next to even number is 6, but 1, 2, 3, 6, 2 is compulsory getting every even number, and 1 and itself are as usual, so they are not the prime. So you can remember one thing, natural number that is divisible by only 1 and itself, okay, is a prime number, and all the even numbers other than 2 are not prime, they are the composite numbers. Now when you come to this prime factors, right, let us take the factors of 24. Previous we discussed. When you come to this prime factors, let us take number 24. So 24 factors are 1, 2, 3, 4, 6, 8, 12 and 24. So these are the factors of 24. Now in this, from this 24, only prime factors. Simple. From the factors, you can find out only the prime numbers. So prime factors of 24. So that is 2, because 1 is not a prime, not a composite. 2 is the prime number. Next 3, 4, 6, 8, 12 are even numbers. 24 is even numbers. They are not. Only 2 and 3. So prime factors of 24 is 2 and 3. Right? Same way. So F 50. Factors of 50. Factors of 50 are 1, 2, 5, 10, 25 and 50. Now prime factors of 50, I'm writing just P dot F. So prime factors of 50. In this, only 2 and 5. Because 10, 25, 50 are not primes. Only 2 and 5 are the prime numbers. So from the factors, you just take only the prime numbers, they are the prime factors. Right? This is the prime numbers and prime factors. Let us start the HCF and LCM, the three different methods. Common factor method of finding HCF. So to find out the highest common factor, let us see this common factor method. So using common factor method, find HCF. Let us take two problems. HCF of 18, 27 and 36. Let's take one more question. 16, 32 and 49. So I'm going to use the common factor method. So in this, first you have to find all the possible factors each given number, right? So therefore factors of 18 and factors of 27, factors of 36. This is the first step. Find all the possible factors of each given number. Now 18 factors. So 1, 2, 3, 6. So which are the exactly number is divisible? Those are 6 and 9 and 18. These are the factors of 18. Factors of 27. So 1, 3, 9 and 27. 1 and itself common. And factors of 36. 1, 2 is the factor for 36. Again 3, 4, 6, 7 is not there. 8 not. Next 9, 12, 3 is the 36. No, 18 times 2 and 36. So find all the possible factors of each given number. From the factors obtained in step 1, these are all the factors, select the common factors. So from this, common factors, second step. Common factors list. So which are the common, those we can take. So 1 is the common, all these 3. And next 2 is here, there is no 2 in this, should be common. Next 3 is here, 3, 3. So 3 you can write. Next 6 is there, but there is no 6. 9 in these two sets, 6 is these two sets, not like that. All the 3 numbers should be common. And 6, If they're not there, no, next to 9. 9 is here, 9 is there, 9. 9. No other number. So only 1, 3, 9 are the common factors. So we required highest common factor. So HCF, highest. In this common factor, which is highest? 9. Therefore, 9 is the answer. 9 is the highest common factor of 18, 27 and 36. Right. Let us see the next one. 16. So factors of 16 you find out. That is 1, 2, 4, 8 and 16. Next factors of 32. Same 1, 2, 3 is not there. Next 4, 8, 16 and 32. Because 16 is there, no? So all will come. Next we have 49. Factors of 49 is 1. Is in 7 tables. 7 sevens are 49. So again 49 itself. Now in this common factors, all three numbers together. Only if you want to find out highest common factor of two numbers, only 2 you can take and common in that highest. 2 and above. Anything. The three numbers, right? Only 1 is the common. 2 is here and here. There is no any 2. 7 49s are not there. So 1 itself. That means therefore even highest common factor. Highest common factor is only the 1. There is no any common factor, then 1 itself, because 1 is only the common factor, that is only the highest now. Right? This is the common factor method of finding highest common factor, that is HCF. Prime factor method of finding HCF. So to find out highest common factor, let us see this prime factor method. We take one question. Find HCF. Find HCF of 15 and 25. So we should write this 15 as the prime factors, product of the prime numbers. That means 15 I can write only product of the prime numbers. So that is 3 into 5. 3 is the prime number, 5 is the prime number. And next 25. 25 also can write the product of prime numbers. That is 5 into 5. So after writing the product of the prime numbers, now in this find out the common. So 3, there is no 3 in this. 5, there is a 1 5. So to find out highest common factor, the method is which is the common throughout. So there is a 5 and 5 is here. So once you write. And 3, there is no 3 in the second line. And 5 is in second number. There is no more, one more 5. So highest common factor of 15 and 25 is the 5. See, one take the two numbers one. Question is find the highest common factor of 24, 12, 36 and 60. We need to find out highest common factor for these four numbers. First step, we should write 24 as product of prime numbers. If unable to find out, take the 24, do with prime number. So first prime number is 2. So check 2 table when this 24. So 2 ones are 2, 2s are 4, right? 12. That means 2 into 12 is 24. Again take this 12, 2 is a prime number. 2 is not possible, next prime number you should take. Okay, 2, 6 are 12. Again 2, 3 is 6. Now 2 is not possible, so 3. 3 times 1 is 3. Until you get 1 you can do it. So product of the prime numbers of 24 is 2 into 2 into 2 into 3. Okay, this 2, 2, 2 and 3. You multiply, you get the same 24. Check it now. 2 2s are 4, 4 2s are 8, 8 3s are 24. Next we have the 12. So take this 12, 2 table, right? 2 6 are 12. Again 2 3s are 6, 3 1s are 3. That means here is same 12 we should take once. Again 36, 60. So after taking this 12, 2 times 2 times 3. Next to 36. Okay, let us take 36 and do with 2. 2 18s are, because 2 ones are 2. 1 carry, no? 16. 2 8s are 16. 2 times 9, 18. Next 2 is not possible, 3. 3 3s are 9 and 3 1s are 3. Now that is 2 into 2 into 3 into 3. Next we have the 60. Let us take 60. 60 is again 2 table. So 2 3s are 6, 0s are 0, and 2 15s are 30. 2 is not possible, next to 3. 3 5 times 15, then 5 ones are 5. Finally this 60 is 2 into 2 into 3 into 5. So after writing, then find out the highest common factor, right? So HCF, to find out this. So same number, 2 is here. All the 4 numbers which is the common numbers you can circle. 2 there is. So once you write, right? Again next, there's one more 2 is in all the 4 numbers. So write once. Next 2 is there, but there is no 2's more. So don't take this. Next 3. So next we have the 3 is here. Is this and this. So write once 3. Now another more numbers, more 3 is there. There's no another 3. 5 is here, no more 5's here. So only all the 4 numbers which is the common, that only should write. Then you can multiply this. So 2 into 2 into 3 to the 4, 4th is a 12. So 12 is the highest common factor. So this is the factor method. Find out the prime factorization concept here, then find out the highest common factor. Division method of finding HCF. So I've seen we saw already the previous two methods. Now division method of finding highest common factor. So let me take the question. Find the HCF. Find the HCF of, let's take two numbers, 36 and 60. So method is same to find out the division method, any problem. Let us see this first one. So in step 1, take the largest number among these two. So divide the greater number by the smaller number. So greater number is 60. Now here is 60 should be divided with the small number, that is 36. So in 36 table, until you get 60 you can write. So 36 times 1 is 36. 36 twos are more than 60. That means 36 into 1 is 36. Okay, now you can subtract this. Writing you can subtract. That is 60 minus 36. Subtract, that is the 24. Subtracting 24. Next, second step. The first step is take the larger number middle, divide with smaller number. How many times? 36 ones is 36. Now for this reminder, now this is a reminder as it is, whatever in this place, this is the dividend divisor. No, divisor becomes as dividend for the next step. This 36 should write here. Now 36 divided by 24. Can continue. So 24 times 1 is 24, because 24 twos are 48, more than that. Now just take this value. Now here is 36 minus 24, so 12. Now next, previous, in this division 24 is the divisor, so the divisor becomes dividend here. So first step, first division, 36 is coming here. After doing division, again this divisor should be here. Okay. Now again this 12 in 24, that is 12 times 2, 24. 0. Until you get the 0, you have to continue this step. After getting 0, which is the last division divisor, so we have the 12, right? The last divisor is 12. The last divisor itself is HCF. So highest common factor is the 12. HCF of 36 and 60 is 12. So no need of taking the factors and all, so you can use this method. Let us see the one more question. Not only 2, more than 2, like find HCF of 18, 24, 32. Okay, these three numbers, highest common factor you have to find out. So let us take any 2 in this. Out of these 3, any 2 you can take first. I'm taking 18 and 24. Find out this method, HCF first. That means take the 24 and divide with smallest number, no, 18. Now the method, 18 table 24. So 18 ones 18. Subtract this. So after subtracting 6. Next, this 18 should be here. This divisor as dividend. Now we can continue the same step. 6 table. So 6 times 3 is 18, 0. So last divisor in this division, the last divisor is 6 is here. Now take this 6 and third number is 32. So now 32 and 6 up to this 2 the HCF is 6. Now take this as the number. Next third number is 32. So among these, which is the largest, that should write in the middle. So up to here you got the 6, right? Now take this 6 and next third number. So since the third number is 32 and HCF obtained above is 6. Now find HCF of this 6 and 32 again. Now 6 table. 6 times 5 is 30. Right? Subtract 2. Now this 6 should be here. We can continue the same process. Now 2 table. So 2 3 is 6. 0 we got. The finally last step the divisor is 2. So therefore HCF is equals to 2. So this is 2 is for all the 18, 24, 32 together. Highest common factor is the 2. Right? This is the division method to find out the HCF. Now let's start the LCM also. 3 different methods. Common multiple method of finding LCM. So HCF we discussed. When you come to this LCM, we have the 3 methods. First one is common multiple method. So let us take the question. Find LCM of 4, 5 and 10. So we're supposed to find out the LCM. So this is the lowest common multiple. That means first you have to find out the multiples of the 4. Find few multiples of each number. So I'm taking M. M4 is just treat as multiples of the 4. That is 4, 8, 12, 16. So complete 4 table, right? So again 20, 24 and so on. 24, 28, 32. So some we can write. First step, find few multiples of each given number. Next number is 5. So multiples of 5. That is 5 table, right? Means 5, 10, 15, 20, 25, 30 and so on. Next multiples of 10. 10 multiples. That is 10, 20, 30, 40 and so on. Now from this we have to take the common multiples. Multiples we did. Now in this the common multiples. So common multiples list is common multiples. All 3 together common multiples. 4 is here. There is no 4 in this. 8 in this 8 is not there. So when you come to this common multiples of 4, 5 and 10. 20. So 20, 20, 20 is here. So write 20 here. Next 40. So if you continue after 30, 35, 40 will come. No? Again in 4 also 36, 40. This is also 35, 40. So 20, 40 and so on it is. Now in this account the meaning of this LCM is lowest common multiple. So therefore least common multiple or the lowest common multiple. That is the first number, the least. So 20. So 20 is the LCM of 4, 5 and 10. Right? Any number is given, you can use the same method to find out. First find out the few multiples of each given number and write. In that find the common multiples, from that the least one. So least common multiple you can take. So this is the way. So any number is given, not only 3, even if it is 2 also you can expect the same. So the question is only 12, 15 are given. So find out the LCM of this. Now take the multiples of 12 and multiples of 15. 12 multiples is 12, 24, 36, right? 48, 60 and so on. 15 multiples is 15, 30. By writing only you can observe the previous. If any two are there, no? So already written one. By writing second number, just observe the previous. 15, 30, 35. Okay. 30, no? Next we have 45. 15 multiples. Next 60. Already 60 is there. So on you can stop. So therefore using this both, the lowest common multiple. So common itself 60 is the starting. Only one number we require. Starting itself the 60. Right. 12 is not here in this 15. So the common is only the 60. So you can stop now. Just keep the dots. So lowest common multiple is the 60. So this is the method, common multiple method to find out the LCM. Prime factor method of finding LCM. So to find out the lowest common multiple, let us see the method, the prime factor. In this prime factor method, let's take one question. Find the LCM. So this method only should be used in this. Find LCM of, let's take the numbers 18, 24 and 36. We're supposed to find out the lowest common multiples for this. As per the previous, common multiple method is very difficult when the numbers are bigger. So we can go for this prime factor method. In this, first you have to find out the prime factors. So already we discussed in highest common factor, right, HCF. So let's take 18 and find out the prime factors. So 2 table, 2 times 9, next 3, 3 is a 9, 3 ones are 3 is this. Next is 24. So 2 12s are 24, again 2 6, 2 3, 3 ones are, right. Next is the 36. 36 is 2 18s are 2 ones are 2, 1 carry 16, no, 8. Again 2 times 9. Again it is 3 3s are 3 ones. After writing the prime factors, that is 18 and 24, 36. 18 is 2 into 3 into 3. For 24, 2 into 2 into 2 into 3. For 36, 2 times 2 times 3 times 3. So after writing this, you can write express as the power. So just to make this in exponential form. So this is 2 to the power 1 into 3 to the power 2. Right. For 24 it is 2 to the power 2 and 2 3 times, no, so 2 to the power 3 times 3 to the power 1. Now this 2 power 2 into 3 to the power 2. So step 1 is express each given numbers as product of its prime factors and then in index form or exponential form. Then step 2, so to find out LCM, now LCM is equals to product of all the prime factors obtained with highest power of each. So here in this complete numbers, only 2 and 3 are the prime numbers. So only 2 and 3. So highest power. So is a 2 power 1, 2 power 3, 2 power 2. Then highest is 2 to the power 3. And 3 is also next prime factor. So which is highest in this? So 3 power 2, 3 power 1, 3 power 2. So 3 to the power 2. So product of all prime factors obtained with highest power of each. Since the prime factors of 2 and 3, so obtained above with highest powers are 2 power 3 and 3 power 2 respectively. So here's 2 to the power 3. So 2 should be multiplied 3 times. 3 to the power 2. 3 should be multiplied 2 times. So 2 to the 4, 4 to the 8 and 3 is a 28 into 3 and into 3. Okay, this is 3, right? So 72 will get. LCM, lowest common multiple of 18, 24, 36 is 72. Okay, this is the main thing. If any factor is not there, so find out the common prime factors, only prime numbers you find out. For all the prime numbers which is highest, you just write. And you can multiply, that will get the LCM. Okay, this is the prime factor method of finding lowest common multiple. Division method of finding LCM. So to find out the lowest common multiple, let us see the method this division method. Let's take one question. Find LCM of 16, 20 and 24. Okay, so these three numbers LCM you have to find out. The first step is write all the given numbers in horizontal line. That is 16, 20 and 24. Separated them by comma. With commas you just separate this. Now divide by suitable number that exactly divides at least two of the given numbers. So just keep the line in this type. 16, 20 and 24. Any common table that is at least two of the given numbers. Okay, you can take the 2. So 2 is the number. Take the prime numbers. If it's not possible, at least any 2. Now 16, 20 and 24. That is 2 8s are 16. Keep the comma. 2 10s are 20 with 2 table only again. And this is 2 12 is 24. Next again keep the line. 8 10 12. Again the table is 2 is possible. So 2 4s are 8. 2 5s are 10. And 2 6 are 12. Now again if you keep the line 4 5 no common table, 5 6 no common, but 4 and 6 2 is the common table, right? So repeat this process until we get the line numbers that are the prime to one another. Now 4 and 6 are divisible by 2, so take the 2. Now 2 2s are 4. When it is not possible, 5 is not there in 2 tables, so just write as it is the number. Only if it is a table, divisibility properties exist, you can write, or else write the number as it is. Now 6, that is 2 3 is a 6. Right, now we got 2 5 3. So 2 comma 5 comma 3, there is no any common. At least 2 should be, right? So there is no anything. Then you can stop this now. So that means these are all the numbers you have to multiply. Now the LCM is 2 2 2 2 5 3. It's complete line. Because 2 5 3 there is no any common, at least 2 is also you have to do it. So we have to repeat this process until we get the line of numbers that are the prime to one another. 2 5 3. So now the answer is 2 into 2 into 2. These three again continue. 2 5 3. 2 into 5 into 3. Just you can multiply these all. The product of all the divisors and the numbers obtained in the last line will be required LCM. So that is 240. Just to multiply. So this way we can find out LCM of finding LCM using this division method, right? And same way using this division method concept only you'll get some other type of questions. I'll show an example. Now the question is find, like word problems type. Find the smallest number. Find the smallest number which, first one, when decreased by 1. When decreased by 1. And second question is increased by 3. Increased by 3. So it's exactly divisible by the numbers like 21, 45, 63, 81 and 210. Okay, this case is exactly divisible. Okay, so divisible by 21, 45, 63, 81 and 210. So smallest number when decreased by 1 and increased by 3. First you have to find out the LCM for these numbers. That is 21, 45, 63, 81, 210. These type of questions, anything, write these numbers in horizontal with commas, separated with commas, and just find out. 3 table we can take directly here. 3 times 7, 3 15s, 3 21, 81, no? So 27 and 3 7s are 21. All we got. Again take 3 table. So 7 is not possible as it is. 3 5s are 15. Again 3 7s are 21. 3 9s are 27. And this 70 is as it is. Next. 5 table because 5 and 70 is there. So this 7 is asked is 5 times 1 is 7 and 9. So 70 is 5 14. So next 7 table. So 7 ones are 1. 9 is asked is 7 twos are 14. So 9 and 2 no common. You can just stop and find out the LCM first by multiplying 3 into 3 into 5 into 7 into 9 into 2. If you all multiply, you get 5670. Now the first question, actually if any number if you take, if you divisible by, now let's take 5670, if you divide with 21, it will remain as 0. Take this number and divide with 45, get remainder 0. Any number among this, if you divide with this number, you will get remainder 0. But they're asking which is the smallest number always when decreased by 1. So decreased by 1 means 1 should increase. So first answer is 5670 plus 1. That means 5671. Now let us take 5671 if we divide with 21. Now you'll get this remainder is 1, decreased by 1. Same we'll get on decreasing 5671 by 1, we'll get this, right? Previous number is 567 you got. Now the answer is 5671. From this number if we decrease 1, that becomes 5670. Now it's exactly divisible. Now this increased by 3. That means take 5670. So minus 3. Increase, no? Subtract 3. Now 5667. This is the required number. Increased by 3. So 5667. If we increase by 3, then you'll get this number. This is exactly divisible. Okay, this is the concept questions you'll see. And whenever they're asking find the smallest number which divided by so and so numbers leaves the no remainder, there's nothing but LCM only. Okay, these are the topics so we can see in this HCF and LCM. And those are watching the first time, you can subscribe to our channel just to go through the topics continuously in order.